Hello, everyone. Ni hao. My name is Alena Prokharchyk. I am a principal software engineer at Rancher Labs. A little bit about myself. I was born in Eastern Europe, and in 2007, I won a green card in the lottery and moved to United States, to California. And starting from 2011, I've been working exclusively on the open source projects in the infrastructure space, and recently with the main focus on Kubernetes. And today we're going to be talking about managing RBAC across multiple Kubernetes clusters. We'll start by looking at when do you need multiple Kubernetes clusters. And I'm actually curious, how many of you manage multiple Kubernetes clusters in production? Cool. And how many of you are writing Kubernetes native applications using the custom controllers and CRDs? All right, so I hope that presentation will be useful for everybody. And so let's get started. And let's look a little bit at the history of the infrastructure. I started with a virtual machine because the virtual machine was a great way to see that there was a need for sharing the resources like CPU and memory. And with the virtual machine came the need for the orchestrating platforms for the virtual machines, like Apache CloudStack and OpenStack. Because infrastructure is more complex, you need the network and you need the storage, and this system has allowed you to configure it. Then, although the containers were present well before Docker made them popular, in 2013, it became very popular thanks to Docker, thanks to the simplicity of its APIs. And similar to the virtual machines, there was a need for the orchestration systems to orchestrate the containers, to lay down the networking between them, the storage, very similar to the virtual machines. So, and the orchestrating system like Swarm, Kubernetes, and Mesos came around. But I think today it is safe to say that Kubernetes is the most popular one. And today, the Kubernetes has become a commodity across private and public cloud ecosystem. You start thinking of like, instead of, I need to provision a virtual machine, you start thinking about, I need to provision a Kubernetes cluster. And cloud providers make it simple by offering you Kubernetes as a service. There are a lot of tools around standing up the Kubernetes clusters on the various infrastructure system, either on premises or in the public clouds. And having multiple clusters is also becoming a new de facto. And more companies have more than one Kubernetes cluster. And let's go over the use cases on when do you need more than one Kubernetes cluster. The first use case is the most obvious one, is the geographical separation. So imagine your application is big and it attracts a lot of users and you have a lot of traffic coming from the different part of the world. And you might want to think about standing up the cluster on per region. Like you have a Kubernetes cluster in Asia, and then you have Kubernetes cluster in the United States. And then you front-face it by the global load balancer with the geo-routing support, ensuring that when your request comes from the Asian users, it will be routed to the cluster that is closest to them. And the question that you might want to ask is, why can't I just provision one Kubernetes cluster across the regions? Because Kubernetes can handle many nodes. And the answer is the Kubernetes components, they don't like to be too far from each other, especially like etcd nodes have to be relatively close, and even kubelet and API server component. So it is better to create a one cluster per region. The use case number 2 for having multiple Kubernetes cluster in an organization is the logical separation driven by the security reasons, where you create the cluster on per project. Like imagine you have a development setup somewhere on premises in your local data center, and your production setup in the cloud where your users can access it. And you might want to apply a different level of protection and, even the logging, turning on the logging on the production setup can be more excessive than on the development setup. And the use case number 3 is also logical separation, but this time it is driven not by the security reasons, but more like a functionality reasons. It's where you create a cluster per team, because different team is a different people, and different people is a different best practices and different preferences. Like one team can prefer to have I don't know, Nginx is a load balancer, and another team might like the service mesh better, and why can't you have both? Like if the system administrator can handle the setting up the clusters based on the requirement, that's a good reason for having multiple Kubernetes clusters, as I said. So we have geographical reasons and we have the logical reasons, and all of them are valid. Now, what are the Kubernetes cloud types? There are homogeneous Kubernetes cloud types. It's where you want to launch your Kubernetes clusters on, like when all your Kubernetes clusters reside on the one cloud provider, they have similar settings. And then there is a heterogeneous or hybrid Kubernetes cloud. It's where your Kubernetes can reside on-prem or in the cloud, and both, or in different types of cloud. I think the most common I've seen among our users is where the users and companies, they had a Kubernetes clusters in the cloud and they had a Kubernetes clusters on-prem. It is less common to have a combination of Kubernetes clusters across clouds, and it usually happens in two situations. When, for example, the company is on AWS and they want to try some different cloud provider for the Kubernetes clusters. Or another reason is that some cloud provider provides some functionality that is very specific to the company's project need. Like, for example, if you use Windows, it would make sense to set up a Kubernetes cluster on Azure. So, and yeah, it is very common that your organization has a different set of the Kubernetes clusters. And there are certain challenges when it comes to the hybrid Kubernetes cloud. So different hosted Kubernetes providers, they have their own authentication types. So Google has one, Amazon has another, other cloud providers has their own. So an authentication strategy on a hosted provider cannot really be adjusted to your company needs. And even if, like, let's say you already have some authentication system like LDAP, or you want to use the GitHub, it's not very easy to do the cross clusters. And when it comes to RBAC, role-based access control, it is a bit tough to set it up on the different Kubernetes clusters. It is possible, and it is possible, like, for administrator to script it, but there better be a better way to do it. So all these challenges brought the need for the missing puzzle piece. So there is a need for the system that would manage multiple Kubernetes clusters across different clouds. And the first piece that there is to address is authentication and authorization across Kubernetes clusters. So, and our goal at Rancher was to build a authentication and authorization management system. That is, here are the requirements. It's got to be open source. All our code is in open source. It's got to be written and developed as a Kubernetes native application. We're going to share more details of what Kubernetes native application is on the next slide. It has to extend Kubernetes APIs using CRDs, custom resource definition. And the logic has to be implemented as a custom controllers. Now, a little bit about what is CRD in Kubernetes. So think of it as a way of extending the Kubernetes APIs. It's where you can describe your resource and you can inject it in the Kubernetes API. So you can use the common Kubernetes client, kubectl, or Kubernetes API to fetch your resources to do the simple CRUDs on them. So, like, for example, like kubectl get pod should be very similar to the kubectl get your custom resource, alert in this case. And then the actual logic behind the custom resource definition is implemented by the custom controller. And what is a custom controller? It is basically the logic that watches for the CRD resource changes. And then it executes some logic based on the resource spec or status, and updates the resource status so the user can see in the API what happened to his resource based on the controller results. And be aware that there can be multiple controllers operating on the same resource, so for that it is better to design your CRD the way that in your status there are going to be multiple conditions and one custom controller will do the updates only for one of them so they do not clash. Now, what is a Kubernetes native application, what it is? Like, I've tried to find the definition online, and I really couldn't. So I've tried to come up with my own based on. So first of all, this application has to be containerized, and it has to be deployed in a Docker container and has to run as a Kubernetes pod. And it has to be launched using either Kubernetes YAML manifest or Kubernetes APIs. And also it is very common for the Kubernetes native application to utilize the Kubernetes constructs like config maps and secrets. So secrets for storing sensitive data, the config map for passing the custom configuration to your controller. And then this is actually the nice bonus. It's not a requirement for Kubernetes native app. It has to be managed using the Kubernetes APIs. So now, this is Rancher. It's open source. All the code is on the GitHub, Rancher. We accept the external contributions, and if you try and find any issues, please file them. I would be happy to fix them. So now, our 2.0 version is a bit different from 1.6. I'm not sure if anybody used Rancher 1.6, but okay, yeah, so 2.0 is very different. And so what it is, so first of all, it is built on top of Kubernetes, which means that it uses etcd as a database. So our 1.x version was written in Java and was using MySQL. So as a developer, I had to convert my skills, my Java skills, and learn how to program in Go. Yeah, so 2.0 is written in Go. And as I said, it extends the Kubernetes APIs. Every Rancher resource is represented as a custom resource definition, and the resources are getting stored in the etcd database. And then functional components run as Kubernetes controllers. That is just a brief summary of what Rancher is. Now let's go over the authentication and authorization cross clusters. Before moving to authorization, I think it's very important to talk about authentication, because that's the first step that your user needs to make in order to gain an access to the underlying Kubernetes clusters. So how is authentication done with Rancher? So first of all, imagine you have multiple clusters and you don't want to go to each and every cluster and configure the authentication like the way Kubernetes does. We wanted to provide the way so you can configure your authentication only once. And we have an integration with a bunch of authentication providers like Active Directory, GitHub, OpenLDAP. We are extending this set based on the user requirements. We are adding more, but this is a basic set. So what happens is the global administrator comes into Rancher and it hooks it up with the authentication provider. And again, it's only done once. And then every user from this authentication provider can get an access to Rancher UI and API. And here's a little bit on the flow and how is it implemented. So Rancher sits as authentication proxy in front of every Kubernetes cluster. So when the request to the cluster needs to be made, it actually comes to the Rancher API. Then Rancher authenticates the request against the authentication provider. If the request is authenticated, it impersonates it by passing the user and group to the request that goes to the Kubernetes cluster. And if the request is not authenticated, obviously the user gets an error. And a little bit about the implementation details. So as you know that Kubernetes itself doesn't have the first class object for the user and groups, but if you manage access for the users across multiple clusters, it does make sense to make user and groups as a CRDs, as a first class object, so you can actually assign some permissions to them and manage them. So yes, we introduced these two concepts into our management plane. And then admin can grant permissions on per user and group to a particular cluster or to a particular project. And underneath, so we are using Kubernetes bearer token authentication for authentication the request to the user cluster. All right, so once the user is authenticated, it is time to think about what the user can do in the given Kubernetes cluster, what kind of resources he can see and work with, and what types of access he can gain to these resources. Kubernetes role-based access control, or RBAC, provides a very nice set of constraints where you can define the roles and the role bindings. In the role, you actually say, you define the resource and you define the operations that can be done on the resource. And the role binding is like a connection of the role to the user. So once the user is connected to the role, he can do whatever is defined in the role. So now, there are two RBAC role levels in Kubernetes. One is a cluster role, and another one is a namespace role. So the cluster role is defined globally, and it is applied across namespaces in the cluster. And the namespace role is applied to a particular namespace. In the multi-cluster management system, there was an obvious need to introduce one more role, above the cluster as you're managing the access to multiple clusters. So we added the global role. And what this global role allows you to do, so it is a new CRD, and it is used to manage users. So there you can define the user's management rules. It is used to manage user roles, and it is used to manage the authentication configs for your authentication providers, like GitHub config, LDAP config. So the global role is an extra that Rancher added to the management plane, in addition to the existing Kubernetes objects. And yes, so it also allows you to manage access to a particular cluster. And there was one more need that we find very important to fulfill. We added one more role in between the cluster and the namespace, and it is called the project role. We find that in the organizations, in the companies, sometimes there is a need for collaboration when users from the multiple namespaces have to collaborate with each other, and the same set of the RBAC rules have to apply to their namespaces. And again, you don't want to do the same operation on multiple resources. So we added this concept of a project, which is another CRD. And what project is, it is actually a collection of the namespaces. And it is a way to define the RBAC rules on per project level, and the namespaces that are a part of this project can automatically inherit them. Yep. And here's an example of one of our custom controllers for the project. So here, the controller subscribes to the add remove events for the user. So user gets added to the project, and there are RBAC rules defined on the project, and the controller will listen for the user creation. And depending on it, it's going to push the RBAC rules to the underlying cluster and the underlying namespace. And once the user is removed from the project, its RBAC rules are going to be removed from the underlying cluster. It's all done automatically. And project is also a nice way to define the infrastructure protection, like the network access, for example, where you want the people inside the project to collaborate with each other without any restrictions, but you want to access between the project to be blocked. Project is also a nice way to specify the pod security policy. You can define the pod security policy on per project basis, and every pod that is launched inside this project will inherit them automatically. And another useful construct on per project basis, you can define the resource quota in the project, and all the namespaces within the project are going to make sure that they are not going to go over the quota that is defined on the project. And here's just an example of how the network policy works. So let's say in your organization you have some stable project and you have a pilot project. The namespaces within the project can communicate with each other freely, and between the project, the access is denied. So today in Rancher, we just have the simple network policies, like do not let projects communicate with each other, but we're going to add more customization into it in the future. All right, so it is live demo time. I'm actually going to launch Rancher and just show how our user interface is built and how you can define whatever I was just talking about. So Rancher itself, as I said, is a native Kubernetes app, and it gets launched as a Kubernetes pod, but it also can be launched in just a regular Kubernetes container. So on my laptop, I have a Minikube running and a Docker, and I'm going to launch Rancher as a Docker container with the Docker run command. So the application is going to listen. Is it big enough, or should I make it bigger? Bigger. Okay. Make it a little bit bigger. Okay, so I'm going to start from our image Rancher, and I'm actually going to use the very latest version, which is not released yet. It's in RC. All right. So what it does is it launches the Docker container, and it actually launches an embedded Kubernetes cluster in it. That's just one way of standing up Rancher. You can also stand it up as a Kubernetes application on an existing Kubernetes cluster, but for the development purpose, it's very easy to set it up in the Docker container. And you can see what's going on. If you look at the logs, you can see that we are creating the resource definition, role bindings, and stuff. So once it's up, okay, a second. It can be accessed on the local host. Come on. So by default, I don't have any provider, any authentication provider enabled. So I just use the username and password authentication. And here, as you can see, there is already one cluster registered into my system. So this is a global view. That's where you actually see all your clusters. And you can add more clusters. So like, remember now you're managing multiple clusters and you have to add them, register them somehow in the system. And there are various ways on how you can do it. You can either let us provision the cluster for you. We have an integration with the hosted Kubernetes providers, like we can provision the clusters on GKE, EKS, or Azure. Or if you already have your Kubernetes cluster provisioned and you just want to manage the authentication with us, you can import your clusters into Rancher. So let's just try that. Just choose this custom import option and the name. And we will give you the command that you will need to run inside your Kubernetes cluster so it can get registered into Rancher. But in the end, you will see all your clusters lined up under the same view. And this is my local host. I also have a setup on the Amazon. Let me try to connect it. Just need to get an internet access. 1 second. Okay, here we go. All right, let's try it. If it doesn't work, I'll just continue using my local cluster, but I hope that it will work. Okay, so it is loading something, but it's doing it very slowly. Let's just go back to the local setup, so hopefully it gets faster. So you start by importing your clusters or registering your clusters with Rancher, and then it is time to set up the authentication provider for the system. And it's going to be like under security authentication. That's where all the providers are configured. And if you choose the GitHub, we use the GitHub auth way of connecting with it. So you just have to go to your GitHub account and register the application with the URL. It's not going to work with the local host. But it's going to be like a regular public. It should be a public IP address once you launch your Kubernetes cluster in somewhere where it's available to everybody. So, but once the users are configured, I think it recovered. Let's go to the authentication where I already have the GitHub auth set up. And this is a place where you can define the rules of who can access your Rancher setup. So by default, any authorized user from your GitHub can access Rancher. And you can actually, and we will do the user and group auto discovery here. Once the user is logged into Rancher, the user CRD or group CRD gets automatically created in the Rancher. And then the question is like, how are you going to access your cluster? Do you need to use Rancher UI API? No. As a user or system administrator, if you don't want to use the UI or API, and if you prefer the native Kubernetes way, you can use the kubectl. And for that, you just go to the cluster view. So there's a global view and there's a cluster view. And in the cluster view, we'll generate the kubeconfig that can be used for accessing your cluster if you run kubectl locally or on your machine. or you can connect to your cluster using the kubectl from the UI. But again, for scripting purpose, most likely you would need to download the kubeconfig and connect to your cluster directly. That is about the authentication and how you connect to your underlying Kubernetes clusters. And back to authorization on what the particular user can do in the Kubernetes cluster. So by default, number of roles can be pre-configured. So here's a bunch of pre-configured global roles, and any user who logs into Rancher automatically inherits the user role. And what is this user role is? If you click on Edit, you will see all the permissions that this user can do. You can define your own roles, but you cannot define the global roles. You can, and here's the on every level for a cluster or for a project, you can define your custom roles, and we also pre-populate some of them for you. And just for example, cluster role. And here you grant the permissions of what this role can do. Like in this case, it can delete and get the apps. Or you can inherit from the existing role. It's just an easier way of creating it. And once the role is defined, you can actually see it if you go to the cluster and go to the members. And when you add a new member to your cluster, you bind it to a specific role that you've just set. Here it is. And the members can be added either on per cluster level or on per project level. So this is the global view, the cluster view, and the project view. Default system are the projects. And let's just go to the on the cluster view, there is a way to set up more projects and namespaces for a particular cluster. So you can add a new project. And you can add members as you add a project. And then once project is created, you can add a namespaces to it. And what happens behind the scene is the project CRD exists on the management plane, but the namespace that you're adding to this project gets propagated to the underlying Kubernetes cluster, and we are just proxying these resources to Rancher UI and API. Right, and as you see, the project that we just added got added automatically into the view. So you can go to the new project view. And if you have enough permissions as a user of the project, you can start creating your Kubernetes workloads from here. But again, you can do it either from the UI, or if you prefer to do it natively from the kubecontrol, you can do it as well. And the RBAC permissions and authorization is going to be done exactly the same way, whether you're going through the kubecontrol or whether you're going through the Rancher UI and API. And this is it. Thank you so much, Sheshe. And if you have any questions, you can either ask them now or you can approach me after in the break. I'll be happy to answer all of them. Oh, there is a question. It doesn't work.
I'm not sure how it works if you have a cluster and that has been, let's say, authenticated with OpenID Connect, for example, the Google ID. Mm-hmm. So you need the Rancher to connect to that cluster. So which permission the Rancher is used to connect?
It's actually for Google. I can show you. Like there's some extra step that you have to make in order for it to be, in order for authentication to work correctly. Oh. But it's going to be the same. So you have to authenticate through Rancher, and then Rancher will authenticate you to that cluster. and we use a bird token approach. So we do create a service account, and then once the user is authenticated with Rancher, we get the bird token of the service account. We insert it to the user request along with the user and group headers, and we send the request to the underlying cluster.
So we actually, when the Rancher calls the members cluster, it does not use a user ID but a service account map to the user.
What is?
I mean, when the Rancher calls a members cluster, does it use a Google ID as an ID token, or
it does not use the Google ID token.
Oh,
no.
okay.
It uses the bird token for all the authentication.
Okay, thank you.
Yeah.
I cannot evaluate the interview. And I found something interesting is when I create a deployment through the cluster's Cubectl, it will never show in the Rancher UI.
Oh, we had an issue. How do you create it? You just Cubectl?
Cubectl direct create to the imported cluster.
Are you adding it to the names?
Not from the UI to create it. I mean.
I'm just curious. Like, can you see your namespace for which you're creating the workload in the Rancher UI? Can you see the namespace?
Yeah, I can see that.
Does it belong to the default project or?
Yes, I have a project.
And the deployment is not showing up. So we had a bug where the deployment that it has owner references are not showing up in the Rancher UI API, and we fixed it in the latest release.
But it's bug. It's a bug.
There was a bug, but I'm not sure if that's what you're. I'm not sure if it's the cause of the behavior that you're seeing. So if your deployment has an owner reference to the custom controller or to anything, then it will not show up in the previous version of Rancher.
So I find two kind of agent in my important cluster is the cluster agent and node agent. So what difference between these two agents?
So the cluster agent, I'm curious why you see the node agent in the important cluster. So usually the node agent gets launched on the clusters that we, like cluster agent gets launched in every cluster that is registered with Rancher. It is used for communicating from the cluster to Rancher. But the node agent, I believe, is only registered when we provision the nodes for you.
Yeah.
So when we provision not only the Kubernetes cluster, we provision the nodes where a Kubernetes cluster is going to be launched. So that's actually for syncing back the node state into.
Node state.
Yeah.
Into the,
yeah.
I see.
Mm-hmm.
Hi, my question is, how does it work if I sync my members with Active Directory like Azure AD? Is a one-time sync or to be connected? It
isn't per login, or like let's say you're adding a group, or you're adding a user. It is not like you have to explicitly add your users to the cluster if you want them to grant access. Or let's say. So you have to define them. So. Okay. So
if I am a public cloud operator, is it possible to integration the Rancher with the Rancher members with my cloud directory, user directory?
I'm not. Today we support only the authentication providers that I've showed you in the demo. I'm not sure how it would work with the cloud, because if it's a cloud, it is not going to work cross clouds, right? Whatever providers I've showed is going to work on every cloud, on every Kubernetes cluster. And if it's in your case, it's something very specific to your particular cloud, I believe there's going to be a need for something custom, like a custom authentication provider. And then it will imply that all the Kubernetes clusters that are registered exist on that particular cloud provider.
Okay, so do you have the plan to open this part?
You mean open to? We actually accept that contribution. So if you feel that you want to add one more provider to the list, you're welcome to do that. We have actually we have this model for a bunch of things. Like for example, for the node drivers that I use for nodes provisioning, we have some default set of what we support. Like we support DigitalOcean, for example, EC2, but multiple customers and users, they want their own, and they can just write their own driver and integrate it into Rancher. I think the same is going to be done for the authentication as well.
Thank you.
Mm-hmm.